Scotty, and I will be doing a presentation on evolution. First, I'm going to start off with the evidence of evolution. The Earth has been around for about 4.5 billion years. Organisms have inhabited Earth for most of its history. Organisms living today share a common ancestry with those from the past. Fossils. Fossils help decipher whether parts of evolution are true or not. Fossils provide a unique view into the history of life by showing the forms and features of life in the past. They tell us how species have changed and evolved across long periods of the Earth's history. Organisms have developed over time. In rocks more than 1 billion years old, only fossils of single-celled organisms are found. Moving to rocks that are 550 million years old, fossils of simple multicellular animals can be found. Gradually, new animals appear. Amphibians at 350 million years ago, mammals at 230, and birds at 150 million years ago. Both flagellated and non-flagellated fungi have an extensive fossil record, which is, however, unevenly documented and often difficult to interpret. But it has provided plausible evidence for all major groups of extant fungi in the Paleozoic era. Key events in fungal microevolution thus probably took place in the early Paleozoic period or the late Precambrian era, and the likelihood of finding definitive fossil evidence for them is small. Charles Darwin. Darwin was an English naturalist, geologist, and biologist best known for his contributions to the science of evolution. He established that all species of life have descended over time from common ancestors. Darwin spent much time ashore collecting plants, animals, and fossil specimens. He also made extensive geological observations. When he returned to England in 1836, Darwin began working with other specialists to catalog his collections. He wondered how organisms fit into their mode of existence. He eventually settled on four main points of theory. Adaptation. All organisms adapt to their environment or die off. Variation. All organisms' traits vary per individual. Over-reproduction. All organisms tend to reproduce beyond their environment's capacity to support them. Natural selection. Since not all organisms are equally well adapted to their environment, some will survive and reproduce better than others. Darwin found many types of remains of ancient organisms. In addition to fossil layers, bones, insects, inambers, and petrified wood, but Darwin never did find animals frozen and preserved in ice. During his journey, Darwin found the bones of an extinct giant sloth, Megatherium. He realized that animals can become extinct and that life is not unchanging. He also saw similarities between extinct and living animals. Darwin wondered how they could be related. Charles Darwin wrote on the origin of species by means of natural selection. The book was published in 1859. While there have been some changes to the theory, such as the incorporation of genetics and DNA, most scientists today acknowledge that there is a wealth of evidence to support the theory. The scientific community broadly accepts evolution as the guided theory on which modern biology is based. Alfred Russel Wallace. Alfred Wallace was a British humanist, naturalist, geographer, and social critic. He became a public figure in England during the second half of the 19th century. Known for his creative views on scientific, social, and spiritualist subjects, his formulation of the theory of evolution by natural selection predated Charles Darwin's published contributions. That is one of his most outstanding legacies. But it was just one of the many controversial issues he studied and wrote about during his lifetime. Wallace's wide-ranging interest from socialism to spiritualism, from island biography to life on Mars, from evolution to land nationalization stems from his profound concern with moral, social, and political values of human life. Wallace and Darwin's forms of evolution describe change through time, but only Wallace's belief that evolution limits the power of natural selection to affect biological change. It suggests that in those areas of the biological world beyond the scope of natural selection operations, some purposive intelligence must be called upon to explain their existence. In contrast, Darwinian evolution claims that all biological life can be explained through a process known as survival of the fittest and mutation. Both Wallace and Darwin were committed to science, but their conceptions of science were dramatically different. For Wallace, science was simply the search for truth in the natural world. For Darwin, science must evoke only natural process and natural laws. Comparative anatomy. Biologists study the body structures of different species. Similarities can point to a common ancestor. The forelimbs of human bats and penguins function in different ways, yet this set of bones is organized in much the same way in all vertebrates. Vertebrate forelimbs are examples of homologous modulus structures. These are simple body parts found in different species. Embryology and physical structure. The body plan of an animal is revealed as the embryo develops. During development, all vertebrates have common features: a notochord and paired pharyngeal pouches. In fish and amphibians, the pouches become gills. In humans, the first pair become a cavity of middle ear and auditory tube. The second pair becomes tonsils, and the third and fourth become glands. This similarity makes sense only if fish are ancestors of other vertebrate groups. Vestigial structures are remains of a structure that served a purpose in some ancestor but no longer function in more recent organisms. Most birds have well-developed wings, but some birds, like the ostrich, have reduced wings and cannot fly. Humans have a tailbone but no tail. The common descent hypothesis explains the presence of vestigial structures. In 1908, English mathematician Godfrey Harold Hardy and German physician Wilhelm Weinberg independently arrived at the Hardy-Weinberg principle. The principle states that the allele frequencies in the gene pool of a sexually reproducing population will remain constant from generation to generation if 5 conditions are met. First, no mutation. Second, no gene flow. Third, random mating. Fourth, no genetic drift. And fifth, no selection. Mutation. A mutation is any heritable change in an organism's DNA. Mutations can occur at the gene or chromosome level. A gene mutation alters the sequence of DNA nucleotides. The alternate sequence creates a new allele. This type of mutation is the main source of genetic variation in a population. Some chromosomal mutations change the number of chromosomes inherited. Others alter the position of alleles on a chromosome. Mutations occur at random and can be helpful, neutral, or harmful. Helpful mutations improve an organism's ability to survive and reproduce. Population genetics is the study of changes in the frequency of alleles within the gene pool. Reproductive isolating mechanism. A reproductive isolating mechanism is a trait that prevents members of different species from reproducing. The mechanism can be structural, functional, or behavioral. These mechanisms are divided into 2 categories: pre-mating and post-mating. Pre-mating isolating mechanisms are differences in body structure, behavior, or location that prevents 2 species from mating. Differences in reproductive anatomy or other body parts are a type of mechanical isolation that prevents the mating between species. These differences in behavior can include differences in mating rituals. When 2 species occupy different habitats, they are less likely to mate and to reproduce. This is called habitat isolation. This prevents gene flow between the populations.
Charles Darwin was the primary scientist behind the theory of evolution. The theory of evolution emphasizes
The survival of the fittest. Adaptation by species continues as environments change. Evidence for evolution is found through many species. Structural similarities in adult organisms, formation similarities in zygotes of the organisms, and in DNA similarities.